Okay, we begin part 2 of chapter 26, dealing with light refraction and Snell's law. I'll remind you that all transparent media have a property called the index of refraction, which is the ratio of the speed of light in air to the speed of light in the transparent medium under consideration. You can twist this equation around and get an expression for the speed inside the medium, c over n. I'll remind you that c is 3 times 10 to the 8th meters per second. I show an interface between two media, perhaps glass below and water above, or water below and glass above. The incident ray makes an angle of incidence, theta 1, with respect to that normal line, that perpendicular line. And then there's your refracted ray that makes an angle of refraction, theta 2, with respect to that same normal line. The indices above and below are N2 and N1. Let's work a sample problem. I show a block of glass, index of refraction 1.50, resting on top of water, index 1.33. The angle of incidence is 50 degrees. Let's ask the following question. Labeling this as point A and this is point B, how long does it take the light to travel from A to B inside the glass? Well, to discover that answer, we will first need to know the distance of travel of that light ray, call it D. I'll point out to you that distance can be found by recognizing that this is a right angle, and so we have a right triangle. The hypotenuse of this right triangle is D, and the angle in question here is not yet known, theta 2. Theta 2 can be found by using Snell's law. We have in water 1.33 times the sine of 50 degrees equaling 1.50 times the sine of the unknown angle, theta 2. You can rewrite this as the sine of theta 2 equals 1.33 times the sine of 50, all divided by 1.50. That means that theta 2 is the arc sine, or you can say inverse sine, of that ratio. 1.33 times the sine of 50 divided by 1.50. From that, I get 43 degrees, rounded to the nearest whole degree. Now, let's return to this right triangle. I'll label that point C, and so we have a right triangle ABC. Hypotenuse length is D. Theta 2 has just been found. It's 43 degrees. And so let us now recognize that the cosine of theta 2, which we just discovered, is adjacent over hypotenuse. It's 10 over D, which means that D, the length of the hypotenuse, is 10 divided by the cosine of 43 degrees. Let me calculate what that is. 10 divided by cos, it's rounded off as 14 centimeters. But we will need, in order to find the time it takes to travel from A to B, the distance in meters, because we'll use a speed distance time equation where the speed will be given in meters per second, not centimeters per second. And so this is 0 0.14 meters. And now our time equation. The time it takes the light to travel from A to B is a distance it travels, which is 0.14 meters, divided by, well, the speed of light in the glass. So we have yet one more problem to solve. What is the speed of the light being in glass? Well, you recall I earlier referenced this equation, which I'll now put to use. We had V equals 3.0 times 10 to the 8th meters per second divided by the index of refraction for glass, 1.50. This gives us 2.0 times 10 to the 8th meters per second. Now the time ultimately is found. T equals 0.14, that's the distance, divided by 2.0 times 10 to the 8th. From this, you get 0.07 times 10 to the negative 8 seconds, which I'll write as 7.0 times 10 to the negative 10 seconds. Final answer. That concludes part 3, or I should call it part 2.